This Zoom session is being brought to you by the fractal Bullseye Bubble Fire. All right, finally doing some actual trigonometry. By which I mean triangle measuring. Okay, here we go. And we'll start with the simplest case, right angle triangles. So this would be a triangle like this, where the angle gamma is 90 degrees, and we have and they have therefore two angles, alpha plus beta. Alpha, beta, 90 is 180. So the alpha and beta are 90 degrees minus the other, complementary angles. Opposite alpha is side A, opposite beta is side B, opposite the 90-degree gamma is side C. Now, all right, because this is a right angle triangle, we have all the right angle triangle definitions of trig functions. For example, A over C is sine alpha and cosine beta. So therefore, if you transpose the C, A is C sine alpha, and it also equals C cos beta. B over C is cosine alpha and sine of beta, like that. Transposing the C, we get the B equals C cosine alpha, and it also equals C sine beta. A over B is tangent alpha. Transposing the B, you get A, hold on. Oh, A is B tan alpha. If you do some, if you transpose the B and then divide by tan alpha, you get B equals A over tan alpha. B over A equals tan beta. Therefore, transposing A, B equals A tan, B equals A tan beta here. And transpose and retranspose, A equals B over tan beta. And also, if we flip these A over C and B over C's upside down, let C over A is 1 over sine alpha and 1 over cos beta. C over B is 1 over cos alpha, 1 over sine beta. And transpose A and B respectively, you get C is A over sine alpha, also C this equals A over cos beta. C is B over cos alpha, and alpha equals B over sine beta. All right, so with these elementary trig definitions, we can, from this angle, 90-degree angle, and one of these angles, and one of these sides, you get the other two sides. We also have the Pythagorean relation that a squared plus b squared equals c squared. Therefore, c is the square root of a squared plus b squared. A is the square root of c squared minus b squared, and b is the square root of c squared minus a squared. We can also, from the definition of tangent, if tan alpha equals a over b, then alpha is arctangent a over b. And if b over a is tan beta, then beta is arctangent of b over a. Of course, given one of these, you can find the of alpha and beta. You can find the other because they're complementary. All right. So, for example, here we have a triangle where we're given angle alpha, that's 35 degrees, and we're given side B, that's 12.1 units. What is side alpha? What is side A? What is side C? What is side angle beta? Okay, generally the easiest part is the other angle. If alpha is 35 degrees and beta is 90 degrees minus that, which comes out to B is 55 degrees. Okay, that's the easy part. Now, all right, we're given B. We want to find A and C. Well, A over B, that's tangent alpha. And B over C is cosine alpha. So from A over B is tan alpha, therefore A is B tangent alpha, and that will be 12.1 times tangent of 35 degrees. Consult your calculator, and out comes A is 8.47. If B is over C is cosine alpha, and we transpose C to the right and cos alpha to the left, then C equals B over cos alpha. That's 12.1 over cosine of 35 degrees. That gives you C is about 14.8. All right. And you'll note that I have 3 significant figures for both of these because B is the 3 significant figures, so it doesn't make much sense to go beyond 3 significant figures for the other lengths. Okay, here we have a triangle where we know alpha and we know A. We want to find sides B, C, and beta. Okay, alpha is 20 degrees, A is 13.7. All right, now, okay. The easiest one, of course, is to find the other angle. If alpha and beta, if alpha is 20 degrees and beta is 90 degrees minus alpha, that's 90 minus 20 is 70 degrees. Now we're given A and we want to find, say, B. Well, A over B is tan alpha. So you flip this upside down and then transpose A, you get B equals A divided by tan alpha, which comes up to 13.7 over tan 20, or about 37.6. Now for A and C, A over C is sine of alpha. So flip it, C over A is 1 over sine, so C equals A divided by sine alpha. That's 13.7 over sine 20. That comes out to 40.1. All right, now here we're given angle alpha and C, the hypotenuse. What are the sides A and B? What's angle beta? Alpha is 42 degrees, C is 17.5. Well, okay, beta, as ever, will be 90 minus alpha. That'll be 90 minus 42 degrees. That's 48 degrees for angle beta. Now, to find A, given C and alpha, A over C, that's sine of alpha. B over C, that's cosine of alpha. And then transposing the C, you get the A equals C sine alpha. 17.5 sine 42, that's 11.7. B is C cosine alpha at 17.5 cosine 42 degrees, that's about 13.0. Now, here we have a right angle triangle. We have two sides. 3 is A and B is 4. What's the side C? What are angles beta and alpha? Okay, here we have two sides, the two short sides. To find the long side, we'll use the Pythagorean identity. C is root A squared plus B squared. In this case, it's root of 3 squared plus 4 squared. That's root 25 or 5. This is the 3, 4, 5 triangle. Now, okay. Now here we have sides 3 and 4. 3 over 4, A over B is tangent alpha. Tan alpha equals 3/4. So alpha is arctangent 3/4, which is about 36.87 degrees. Tangent beta is 4 over 3, so beta is arctangent 4/3, or about 51.13 degrees. And of course, given alpha, we can find beta by subtracting 90 minus this, and you get the same result. Here we have a triangle. We have the hypotenuse, the diagonal, and one of the sides, A, equals 1, C is 3. What's the other side, B? What are the angles beta and alpha? Okay, here we go. Now, given this thing, use Pythagorean relation. Here, one of the short sides is the square root of long side squared minus the other short side squared. B is root C squared minus A squared. So that'll be root of 3 squared minus 1 squared, which is root 8. You can pull out a factor of 4, root 4, root 2. So B is 2 root 2. Now, all right. We have all three sides, but I always recommend using what I call the freshest ingredients, namely the ones, the information starting from what you're given rather than what you derive. Because what you derive may be wrong, it may have approximation errors and so on. So here we go. We have side A and side C. Alpha, that's opposite over adjacent. So sine of alpha is 1/3. So alpha is arcsine 1/3, which is about 19.47 degrees. All right, now for beta, A is adjacent and C is the diagonal. So 1 over 3 is adjacent over hypotenuse, the cosine of beta. Cosine beta is 1/3. Therefore, beta is arc cosine of 1/3, which is about 70.53 degrees. Just a second. Here we have, here's one which requires some cleverness. Here's two buildings, this one here and this one here. This taller building is 2,001 feet high. And from here, when you go to the base of the other building, it has what's called an angle of elevation, 35 degrees. You have to crane your neck up by a 35-degree angle to see the top of the second building, the taller building. Whereas if you take the elevator to the top floor and get out on the roof, and then you have to crane your neck up by 15 degrees to see the height of the other building. And this is an angle of 35 degrees. This is an angle of elevation of 15 degrees. This has height 2,001 feet. So the question is, what's the distance between the buildings, and what is the height of the smaller building? Okay, first what I do is I draw this horizontal line here, and this h is the same as this h here. Let's call this k, this remaining distance k. So h plus k is 2,001 feet, so k is 2,001 feet minus h. We'll deal with that. Now, okay, and d is the distance between the, okay, here's d, side d. Here's a 2,001 feet side, and here's an angle 35 degrees. Opposite over adjacent is tangent 35. So 2001 over d is tangent 35 from here. If we find reciprocals, then transpose 2001 feet. Then d equals 2001 feet divided by tan 35 degrees. That comes out to about 2857.7 feet. I add one extra figure of accuracy, although that's a little more than really justified, but I think that's a good idea just to be a little bit more accurate than required. So, okay, that's the distance between the buildings. Okay, here's 2857.7 feet. And let's see, this distance k is 2001 minus h. And it's at an angle of elevation of 15. This is d, this is k. Tangent of 15 is k over d. And so therefore, after some, therefore k, that's 2001 minus h feet. D is 2857.7 feet. From here, let's transpose the 2857 and do a little more algebra from here. You get this. H is 2001 feet minus 2857.7 feet times tan 15 degrees. And after a bit of churning, you get H is 1253.3 feet. So the buildings are 2,857.7 feet apart, and the shorter building is 1,235.3 feet high. Okay, that concludes that part.